So this experiment is diode as a temperature sensor. The aim of this experiment is to study the volt ampere characteristic of silicon diode at different temperatures and to find its voltage sensitivity. So this is a circuit diagram. First we will start from the battery. So the positive of the battery goes to the positive of the diode, which is the red one, and the negative of the diode then goes to the positive of the ammeter. This is the negative of the diode and to the ammeter, to the positive of the ammeter. Then the negative of the ammeter goes to the key, and then the key comes back to the negative of the battery, and then we can connect the voltmeter across the diode like this. So this experiment has three parts. First we will do it for water at lab temperature, then at warm water, that's boiling water, and ice. Before we start the experiment, we need to make sure that the diode is fully immersed in the water and that when you're taking the reading for temperature, the thermometer is not touching the diode. Then to start with the experiment, for us we have varied with 0.2 volts, but you can vary it however you like so that you can get good readings for the graph, to plot for the graph. So while taking the readings, we can stop at around 100. As you can see, the graph cannot exceed more than 105 or 110. So this is the model graph for current and voltage, and this is the graph that we got. So first you plot for ice, then normal water, and then boiling water. And after you take the points, you have to draw a tangent across these lines, and you will get your knee voltage. So as you can see, as the temperature increases, the knee voltage shifts towards 0. So as you can see, the point where the graph bends, we are going to take a tangent from there, and the point where it intercepts with the x-axis, that is going to be our knee voltage. So these are the values of knee voltages that we got for the respective temperatures. After that, we are going to find delta V1 by delta T1, that is V2 minus V1 by T2 minus T1, and similarly delta V2 by delta T2 and delta V3 by delta T3. After that, we are going to take to find the average, we are just going to add up these three values, and here we got as 1.36 into 10 to the power minus 3, and this will be your rate of change of knee voltage with respect to temperature. So to take the reading, we are going to vary our voltage from here, but we are going to take the reading from the voltmeter because this is supposed to measure the voltage of the whole circuit, but this will measure only for the diode. So we are going to start by varying the voltage to 0.2 volts, and at 0.2 we are getting -3, but that just means that the ammeter has an error of 4 milliampere. Then if we see and take it till 0.6, the 0.67, we have 1 milliampere, and from 0.7 is where we can start the reading. 5. So as you can see, till 0.6 our values for current come as 0, and then from 0.7 our values start increasing, and like that you are going to vary it till, as we said earlier, till around 100. And similarly we will do it for ice and boiling water.